Assalamu alaikum wa rahmatullahi wa barakatuh. Today we continue our course for the KNX Certified Basic course. Last sessions we talked about the introduction about smart homes and KNX in general, and we also talked about the arguments, and we talked about the role of KNX association and what are the benefits and unique proposition of the KNX system in general, and what you get as a KNX certified partner by putting your name on the KNX association website, and other benefits we talked about in the last two sessions. Today we'll start talking about the bus devices. From now on, the KNX will start taking each part of the system, trying to simplify and put more details onto it. And then at the end, in the past two chapters, we'll start getting the whole picture. So it's normal in this case that you find or you feel that some of the parts are not really clear, but they will be clearer and really clear by the end of the course itself. Okay, so today we start with the bus devices. It starts here with the abbreviations. So what kind of abbreviations we have? We have something called PEI. This is a physical external interface. BCU, this is the bus coupling unit. AM application module. TRC, this is the transceiver. SR, shift register, DAC, digital analog converter. We'll talk about those in details in this course today. However, it's nice to know that these are the abbreviations that we're going to use most of the time today. Last time, if you remember, we talked about that the device of the KNX can be divided into two parts. One part called application module and one part called BCU. Okay? Here it's trying to show you this. So the part related to the KNX, so the device you have will be, one part is connected to the system or to the TP wires, and one part will be related to the interface of the user itself. So the part that is connected to the bus system, okay, the KNX, is called BCU. This abbreviation of what is bus coupling unit. This unit is responsible for transferring telegrams and getting the KNX logic. It has a microcontroller for controlling telegrams, sending and receiving telegrams from the buttons or the application module to the KNX system itself. Then you have the other one, which is connected mostly to the related to the user side, which is called the application module. Both are connected together using a socket called PEI or a physical external interface. So now we know that there's a bus coupling unit, and then there is a PEI interface, and then there is application module. Let me show you how this in real life. It will make your life easier to understand it. Okay. I stopped sharing. So now this is in general, this is one sensor or button, okay, where you put it on the wall, where you can control scenes. So normally it's like that. This is the whole one. Okay, this is the whole one. It will be on the wall, and then you can control scenes from here or push buttons from here. When you divide it, okay, this is the plastic interface for the button itself. It can come in black or white or whatever. Okay, so this is not really into the electronic part. And then you have this, and you can divide this. Now you have this. This is the application module. Okay, and this is the BCU bus coupling unit device. And this is the one connected to the KNX side, because it's connected to the KNX side using this interface. This one. We'll talk about this in the installation, but then you put the cabling in here, and this is in the wall, and then you attach this one, this application module, to this one by this socket. You see this socket? This is the physical external interface. When you attach it like that, now we have the unit, and then this is the plastic part where you can put it together or remove it depending on the uses that you need. So in the cases like that, it's detachable. So you can see that this unit, the application module, can be detached from the BCU. In other units, like let's say actuators or units like that, this is one unit. This one is an IP interface. It will be in the DB. It will not be for user to view, but it will be in the DB. We'll talk about that. Like relays, like dimmers, actuators in general. Normally, you cannot detach. So you can see there is not an easy part to detach. So the application module and the BCU, the bus coupling unit area, is both on one unit. You cannot detach. Okay. Let's share the screen again. We're back. So this simply, you can find out, you can see that, so the unit you can divide normally and on the, from the KNX side as a bus coupling unit, and then socket, a small socket called physical interface, physical external interface, and then the application module. And the physical external interface doesn't have any logic, by the way. It's only a socket to make sure that the application module and the BCU are detached together and gives the power from the cable to the application module itself. That's it. However, the BCU is the one responsible for most of the logic of the KNX part. If we take the BCU and talk more about its functions, you can find that it will have a shift, a coupling function called transceiver. The transceiver function is to take telegrams or traffic from the KNX side and put it to from the give it to application module and vice versa. So when I'm clicking on the button as an example, I'm sending a telegram from the button to the BCU, from the BCU to the KNX bus, from the KNX bus to other systems that will control maybe lights or something, and vice versa. So it's the transceiver is in the BCU. There is also microcontroller in the system, which is responsible for the logic and taking action. And of course, the electronic circuit, which is taking the port. I mean, if in case of a relay, this is the electronic circuit that is shutting off or switching on the light itself. In the KNX side itself, there is a memory. The memory can hold system software, like the application software, and it can also hold parameters or programming logic, group addresses, and it also has a RAM part when you have the temporary values of the system itself. When you are doing the practical part, you will find that normally you put the device and then we install the software on the device. So if I have an actuator, let's say from ABB or from Schneider, I tell the system that I have an actuator and I start downloading the software of this system, of this actuator, on the actuator itself. However, we have here an issue. Let's say by mistake, I'm downloading a software from a different manufacturer or from a different actuator to the actuator I have in my system. So no, it's if we take it analogy like our systems, let's say I have a mobile and I'm trying to put a firmware on this mobile, but a different version. In here, we have two actions that can happen. If the manufacturer is different, then the BCU will detect that the manufacturer is different and will not allow the transfer. So when you are downloading from the ETS, a different manufacturer of the software to a software from different manufacturer, the ETS will give you an error and the download will not take place. However, if the manufacturer is the same, then the ETS might allow downloading. So I might have an actuator from ABB and then I'm downloading a dimmer on a switch. The download might happen since it's the same manufacturer, BCU will not check that. However, the device will not work because we are trying to tell it to do a different function that is not designed to. In this case, if you download the new version again, it will work. So no permanent damage will take place. Okay? And this question may sometimes come in the exam. So what are the reasons that download failed? Mostly because the manufacturer is different. And if the download happen, then no harm will be done to the system itself because then you can re-download the correct version and go on. Bus devices came with versions. So the version here we call it in KNX a system profile. So the first system profile, okay, was system 1, then system 2/7 came, and then system B came. The difference between the systems or among the systems is very unique. The mask version, so the systems has a version, and in KNX we call this version a mask version or device descriptor type 0. Okay, this one. So when they say that the mask version or device descriptor type 0 is system 1, you know that they're talking about system 1 or 2/7 or B. System 1 is not used anymore, it's too old. but mostly you'll find in the current devices, system 2/7 or system B. And the difference between 2/7 and system B is mostly in the RAM and capability of the microcontroller. However, the difference between system 1 and those two systems is huge. So the maximum number of group objects in system 1 it was 12, in system 2/7 is 254, and then it's more than 56,000 devices, 56,000 devices on system B. So in system B have more memory that can allow to take more devices than system 2/7 or system 1. System 1 was the basic one. Okay, what is group objects? We'll find out in the next sessions that group objects are parameters and systems to allow interface in the programming itself. So take it for now like a variable or something like a programming unit. So if you have more memory, you can have more programming unit. If you have less memory, then you can have less group objects and less programming unit. So in system B, you have more than system 2/7. Then in those new systems, three new things were introduced. First, you have the interface objects, and this is also programming hierarchy or structure to allow different manufacturers to interface devices together. We'll talk about them in details, but for now, you have to know that there's something called interface objects, making that if I'm putting a button, let's say from Gira and control it, and I wanted to control a relay from, let's say, Schneider or ABB, there should be an interface object, a programming unit telling me that this one can interface with this one can talk to this one. Okay, in this our case, if it's a non-off, then there is an interface object, let's say with 1 bit size, to take a non from the button and send it to the relay itself to allow the lights to be on. Okay, so there's an interface object that was introduced on those new systems. And then there's also a KNX serial number and the access control. Let's talk about serial number and access control in more details. Serial access control is a security feature that was allowed on this system 2/7 or system B, meaning that, let's say today I finished my project and I don't want anyone to do changes in the project. So he has the project file, the programming file, the ETS file, and I don't want him to start doing changes and put new parameters on my system. So I use something called BCU key. Okay, BCU key we'll see in the practical part. BCU key is a password that you put in your system, and then it's on the BCU itself, it's on the device itself. And if I don't put the right BCU key, then the device will not take any changes itself. So the system will still work, but if I want to do changes to the system, I have to put the BCU key. Okay, so that is a measure of security in here. By the way, if you forget the BCU key, the only way to recover the device and get it back to the factory default is to send it to manufacturer itself. So there is no workaround that you can do as an integrator. The only way that if you forget the BCU key is to send it back to manufacturer. It will reset it to factory default and send it back to you. Okay, but the operation will be normal even if you don't know the BCU key. You only need it if you want to make changes to the installation that you did. Okay, the other part is serial number. Serial number is meant to be a unique number for each device, something like that. Okay, so each device coming from the factory should have a unique number called serial number. The serial number, until now, we don't have any function for it in the operation. So ETS is not using serial number for now. It can read it, but there is no usage for it now. In the future, they are planning to implement some kind of security mechanism using the serial number, but for now it's not implemented. And we're not using it in the operation. We are using different addresses and numbers in the operation. So this is the access control and serial number. They were introduced in the system 2/7 and system B. And by the way, if you have a system 1 software, you can put it on system 2/7 because there is backward compatibility. But if you have a software of system 2/7, you cannot put on system 1 because simply the hardware will not allow to take the higher part of the system 2/7 to the small part in system 1, because system 1 was very small in memory and very primitive or primary in its functions. Now we'll talk about the functions that we are going to use later in the practical. So we'll talk about the on-off relays and the dimming and the motor functions. Okay. The behavior of the dimming in KNX is very simple. So you have a dimmer, which is connected to a dimmable load. So this is your dimmer connected to a dimmable load like LED or something. Dimmable loads meaning that I can control the intensity of the light. So it can increase or decrease depending on my usage. And then you have a keypad or a button like that, okay, where you are using this button to control the dimmer. So the behavior is very simple. If I'm holding the dimming for a long time, as long as I'm holding, then the dimming is increasing or decreasing based on the time I'm holding the dimmer. Once I release my finger from the button, then the dimming stops. Okay? And if I press a short press like that, then if the dimmer is on, it goes off. If the dimmer is off, it goes on. So very simple. If I want to increase the dimming or release the dimming and I use a long press, I keep pressing until I reach the dimming value that I need. And then I remove my finger. It's like that. If I want to turn it off, I just do a short press. If I want to go do it to make it on, I do a long press. It will come back with the value that I left it on. So if it was dimmable for 50%, it will come back on 50%. If I want to decrease the dimming again, then I keep pressing again. I found that the dimming is decreasing. And this is what you are seeing here. So if I have here the smart dimmer, if I start long operation, and let's say the dimming was on 0 value, if I'm doing long operation, so I'm keeping my finger on the button, so you can see that the dimming is increasing. Then once I remove my finger, okay, so I stop dimming, the value is like that, خلاص. So the value is fixed on this. So the light is on this value. If I want to switch it off, I do a switch off using a short press. Now it's 0. If I press a short press again, it will go on to the value that I left it on. Okay. And after some time, if I want to press to decrease it, I start also doing again a long press, so it starts to be decreased. And that's it. This is the dimming function, and this will do practically on the course and in the practical exam as well. The function of the dimmer itself, you can see that this is a part of the KNX. When you see the BCU, then you know this is a part of the KNX here. The KNX port is here. Okay, so this is the BCU, and its function is to take telegrams and commands from KNX system, pass it from the PEI, the physical external interface, to the application module. And the application module got the functions related to the load. So if it is a relay, I find here relays to do the on and off. If it's dimming, then it's devices doing the dimming. And in the dimming, you have always two parts. Part for the dimming and part for on off, because I can just switch off or switch on the relay itself. So here, this is a relay that's connected to the dimmer itself. And from here, I can switch on and off the dimmer itself. And from here, from shift register and the converter, I can just pass parameters and pass voltage that will allow the dimming part to be the light to go on to a specific value or off to a specific value. Okay, so this is the load part, and this is the KNX port, the one on the left. Okay, you don't need this for the exam, by the way, but it's trying here to give you an idea how the device looks like. In the shutters, when shutters, I'm talking about curtains, about maybe even garage doors, blinds, anything related to this movable part like that. Then this is a different way. In the shutters, similar to the dimming, but to an extent. So in the shutters, if I'm pressing the button for long press, it means to the shutter that go up or go down, or open and close in case of garage door as an example. So long press, it will start going up or going down. If I remove my finger, it will keep. If it is going up, it will keep going up. Okay, if it's down, keep going down. Not like the dimmer. When I remove my finger from the dimmer, then it stops. Here, no, it will keep going up or down, opening or close, because they have a travel area, a travel period for the motor to go. Okay? And if I press short press, it has two actions. In case the motor is working, I mean the blinds or the curtains are going up or going down and in movement, when I press here, the movement stops. And if it's not in movement, if it is already stand still, when I push here a short press, it will move up or down with a specific step. So not going up or down all the way, but specific step, small step. Okay. So again, I have the shutter or the curtain, and then I keep short pressing. It's moving up. I remove my finger. It will keep moving up until it opens. If I want to pause it in the middle, I don't want it to open or close the entire area and want to pause it in the middle, then during the movement, I do a short press. If it is already open or closed and I want to open it reverse direction, but in small steps, then I keep pressing short presses on the button. Okay? Good. There is also something here. Normally, the motor itself has some parameters telling it that when you reach a limit control, when you reach your limit, stop moving. Otherwise, it will just be rolling like that. So in the motor itself, not related to KNX part, but in the motor itself, there is a limit switch in it that making it stop when it reaches its maximum, meaning that if the garage door is open, then it will detect that the garage door is open and it will stop moving anyway. Even if you are still giving it power and giving command to still moving up, خلاص, it will stop. And vice versa. If it's down, then it will not move down again. Okay? So in your configuration, you can configure time in the parameters, in the KNX, to tell it how long should you keep giving power. So I kept pressing here. So the KNX is sending to the system to move the motor up. For how long should it keep the motor up? Normally, there is a time that you get from the file of the motor itself telling you that the entire duration from down to up, let's say 10 seconds or 5 seconds. Normally, what you put here is slight number above this. So if it is taking 10 seconds, so I know that the motor from down to up, the entire journey will be 10 seconds. In my parameters in KNX, on the driver itself of the relay, I put, let's say, 11 or 12 seconds, meaning that if I kept pressing here and then I move my hand, my finger, then after 12 seconds, automatically it will stop. It will not send power anymore. Okay? And this is why the timings are here. So depending on the time you are putting, then you are controlling the motor up and down. Also, depending on the time here, the T1 and T2, you are telling the system, if I press, if it is less than T1, then it's short press. If it's more than T1, it is a long press. Okay? And then the motor itself as a direction, you can see that the motor itself normally has two interfaces, one for up and one for down, and then the normal one, the neutral one. And then from the relay wise or from the shutter wise on the KNX port or the actuator port, you connect one from the relay to the up direction of the motor and one from the relay to the down direction of the motor, and that's it. So in general, by the way, if you are having a single relay, it will control light. But if you want to use this relay to control motors, you have to use two relays, one to allow up operation and one to allow down operation, or right and left in case of curtains, or open and close in case of garage doors. Okay. Now we're done with this session. I will see you in the next session, inshallah. If you have any questions, just send it to us. We'll answer in the next session. And see you.